Here in the I button and the description box below, you will get the complete playlist of complex numbers. Welcome to video number 1, and in this video we are going to see the certain basic concepts. So let us start. Suppose you have this, that is root 4. What is root 4? That is 2, not 2. It is plus minus of 2. Similarly, if you ask like what is root over of minus 4, okay, so we cannot find the value, the real value of this. So we will convert this as root over of minus 1 into 4. Okay, now we can separate this, that is root over of minus 1 into root over of 4. Okay, what is root over of 4? That is plus minus 2. What is this? That is root over of minus 1. This is I. Okay, so if you get I, you will find the number as complex number. Okay, whenever you find this I, then the number will be complex number. And what is this I? This is imaginary unit. This I is imaginary unit. Fine. Now complex number can be written as z equals to x plus I y. Okay, here we have plus sign, so we have two terms. This is real term, this is the real part of complex number z, and this is this y, not I. This y will be imaginary part of complex number, that is z. So we can say real part of z. This z is what? This is a complex number. Okay, so we are finding the real part of z, that is nothing but x, and we can say x is the real part of z. Similarly, if you want to know what is the imaginary part of this z, that is y. So imaginary part of, sorry, this is z. Imaginary part of z is what? Is y. So this is imaginary part of z. So x is the real part of z and y is the imaginary part of z. Now suppose x is 0 and y is non-zero. That is, if x equals to 0 and y is not equals to 0, then z equals to, what is z? Z equals to x plus iy. Here we have z equal to 0, so z equals to I into y. I into y. Then we can say this is purely imaginary because nothing is left regarding real part. Okay, so we can say this is purely imaginary. In the same way, if you have, if x is not equal to 0 and y equal to 0, that is, if x is not equal to 0 and y is equals to 0, then z equals to, y becomes, if y becomes 0, then z equals to x, then z equals to x. Okay, then we can say z is real. Okay, z is real because there is nothing like I associated with this z. So z equals to x means this is real. Now after this we'll come to three note points which are very important. So note point 1, what is I? This is root over of minus 1. Okay, now squaring both sides, you will get I square equals to minus 1. Okay, now if you want to find I cube, what is I cube? That is I square into I. What is I square? That is minus 1. So minus 1 into I will become minus I. Okay, now suppose you want to find I to power 4, that is equals to I square into I square. What is I square? That is minus 1. Okay, so minus 1 into minus 1 will become 1. Similarly, you can find I to power 5. What is I to power 5? That is I to power 4 into I. What is I to power 4? That is 1. 1 into I will become I, and so on. Okay, so what we can observe is, yes, that is even power of I, that is I to power 2, I to power 4. It is either minus 1 or 1. Okay, I square is minus 1, I to power 4 is 1. In the same way, if you want to find I to power 6, that means I to power 4 into I square, 1 into minus 1, that is minus 1. Okay, that means I to power 6 is minus 1. In the same way, if you want to find I to power 8, that is I to power 4 into I to power 4, 1 into 1 will become 1. So you can say even power even power of I is either 1 or minus 1. Fine. Yes. Now I cube is minus 1. I to the power 5 is I. I cube is minus I. I to the power 5 is I. In the same way, if you want to find I to the power 7, that means I to the power 5 into I square. That is I into minus 1 minus I. And if you want to find I to the power 9, that is I to the power 7 into I square. What is I to the power 7? That is minus I. Minus I into minus 1 will become I. So you can see the odd power of I, that is I to the power 3, I to the power 5, I to the power 7, I to the power 9. The value is either minus I or I. Okay. So we can say odd power of I is either minus I or I. Okay, this is a very important observation. That is, even power of I is either 1 or minus 1. Odd power of I is either minus 1 or I. Okay, now coming to the second note point. Suppose you have two complex numbers z1, z2, and we are saying both the complex numbers are equal. Okay, then what should be the required condition? Two complex numbers are equal if and only if their corresponding real and imaginary parts are equal. Suppose you have z1 equals to x1 plus I y1 and z2 equals to x2 plus I y2, and we are saying that is z1 equal to z2 when it is possible when x1 is equals to x2 and y1 equals to y2. So we can say if x1 equals to x2 and y1 equals to y2, then we can say z1 equals to z2. This is very important note point regarding this. Now coming to third note point. If z equals to x plus I y is a complex number, then its conjugate, or you can say complex conjugate, is given by z bar equals to x minus I y. Suppose z equals to x plus I y is any complex number and you want to find the complex conjugate. Okay, you can say conjugate or complex conjugate, and it is given by, simply put a bar on this z, that is z bar equals to x minus iy. You have to change the sign of this. If it is positive, then write negative. It is negative, then write positive. Okay. By this way, you can write the complex conjugate of any complex number. Okay. Thank you.